Very good morning to one and all for this day 4, a 5-day online international workshop on role of artificial intelligence and applications to emerging technologies held from 10th June to 14th June 2025. Today we have our resource person, Mr. Abdul Karim, is a PhD scholar at University of Michigan, Dearborn, and his topic is AI applications to robotics and cybersecurity systems. So now I take this pleasure to introduce Mr. Sheikh Abdul Karim. It is my pleasure to introduce Sheikh Abdul Karim. He has pursued his Bachelor of Technology at P.V.P. Siddhartha Institute of Technology and his Master's in University of Michigan in the field of robotics engineering. And now he's pursuing his Doctor of Philosophy in robotics engineering. So he acted as a junior research fellow in Mahindra University from 2021 to 22 and has completed his master's in 2023 March. And he is a entrepreneur leader trainee. And also he is working under Dr. Hafiz Malik sir in the projects of automotive cybersecurity. That is an NSF funded project, cybersecurity of industrial robots, liveliness and integrity verification examiner, cybersecurity of audio, NSF funded project, and a sensor node for monitoring of livestock farms using IoT. So he had an experience of 5+ years on hardware knowledge on embedded systems and LabVIEW environment, and also have a research experience on power electronics and renewable energy resources, have a good knowledge on Python, C, Arduino, and also DSP, LabVIEW, embedded, and FPGA controllers. His area includes development of human interaction robots and IoT, and so which was his current research. So I welcome you, Karim, for this workshop. So definitely your research and your ideologies which you present today will be very much helpful to our participants. Thank you. Over to Karim. Karim, your voice is not proper. Karim?
I'm audible, ma'am?
Yes, you're
perfect.
audible.
Thank you so much, Bhavana madam, for the great introduction. And it's my pleasure to be here. And first of all, good morning, everyone. If you are in India, it's good morning. If you are in USA, it's good evening. So first of all, let me start my presentation. Screen to share. I guess you guys can able to see my screen. Ma'am, can you see my screen?
Yes, Karim.
Okay, ma'am. Perfect. So first of all, I want to start with today's concept, which is the use of AI in robotics. In today's session, I'm not going to focus on all types of robots, which are mobile robots, four-legged robots, animal-inspired robots, humanoid robots. In this session, I'm going to focus more on industrial robots, and the other part of the section, which is the security of cyber physical systems. In fact, that's going to be the major part of this today's session. So I want to introduce myself like a little further. Now, actually, Bhavana madam already have covered almost everything about me. Currently, I'm pursuing my PhD in robotics engineering at University of Michigan, Dearborn. And my current research is in cybersecurity of industrial robots. And it's there is a very interesting story behind why I chose this concept. And I'm going to explain you how I started this concept and what is the motivation behind. So earlier, when I came to USA for the first time, I started with in-vehicular network security, which is the security of uh, in-vehicle networks, which are CAN, automotive Ethernet, LIN, and FlexRay. So my major focus was on CAN, which is controller area network, and then now I'm currently working on automotive Ethernet as well. And it was a fortunate that I got selected for national NSF ICOP training. It was a really great opportunity that this opportunity that it's like once in a lifetime opportunity. And alhamdulillah, because of my professor Dr. Hafiz Malik, all thanks to him, because of him I got selected for this one. And fortunately I was volunteer for IGOS 2023. uh, for your information, IGOS is one of the biggest robotics conference in the whole world. So this time, the 2023, fortunately, that happened in Detroit, which is like neighboring city of my location. So fortunately, I got selected and I was volunteered. So these are the publications and the patents that I have. So this paper, which is published recently, which is May 20, 2025, and it's on cyber security and vulnerabilities of industrial robots through their sensing system. If you guys are interested, like I'm going to take another session tomorrow, probably again same time, and that session is purely based on this concept. And today I'm not going to touch this concept in detail, but tomorrow the concept is purely on this topic. And the next paper that I have is it's on IV curve tracer and fault detection of solar panel. So if there is an array within the solar form, if there are thousands of solar panels, if one of the panel is faulty or few panels are faulty, it's really hard to find out which panel is faulty. What usually technicians do is they'll go and they'll check every single panel, but that's really tough if we have thousands of panels. So this solution, which will gonna is the whole problem, which is it will gonna uh, first identify and localize which panel is faulty, and it will inform to the control room. And I have 4 patents, and it's my pleasure that my first patent, which is the life rescue robot that I usually call, which is patent 2 here, that is with Bhavana madam and my friend Gunashekhar. And the other 2 patents are on solar, because back in India I worked as junior research fellow in Mahindra University, so I worked on solar embedded systems. So the patent 1 and patent 3 are related to that. And in patent 4, we have built a automated name reading system. This is an interesting story. I mean, I'll take a few minutes, like hardly 2 to 3 minutes to explain this one. So, as an Indian, like it's really hard for an American native to pronounce an Indian name. It's really, really, really hard. So, if the name is like at least five to six words within the name, then that like they'll find really really hard time. So during the graduation day, which is going to the biggest day for a student in his whole education career, so during that day, if they are pronouncing his name in a wrong way, then he'll be embarrassed in front of thousands of people. So to resolve that, we build this system. So it's an automated name reading system. So instead of instead of people instead of the host is pronouncing the names, student can record their name, and they can submit into this automated system. When they're on the stage, they'll be given with a card. So once they're on the stage, they'll hand over the card to us. We'll scan the card. Once they scan the card, so the system will pronounce the name. And in fact, even for this one, we have used AI, because while recording, few people will be they'll record with a loud voice, they'll record with a very low voice. So this system can normalize the audio based on deep learning model. And there is one more, yeah, this patent 3. This patent is also purely based on AI. So there is a AI model which detects the patterns of solar panel. So based on that, it will identify which panel is faulty. So it was a good project. So these are the patents and publications that I have till now, and I have published a thesis, which is my master thesis. I'll be discussing that thesis in the tomorrow session. Probably that's going to be one of the interesting sessions. Yeah, I want to jump into industrial revolutions. I still remember that my first patent, which is life rescue robot, which is also purely depending on this industrial revolution. So actually, industry is moving at a very really fast pace. Right now, they are still stick to 4.0. I don't know where when they're going to 5.0, but the first industrial revolution, it was purely mechanics. There was no electricity. And in the second industrial revolution, there was electrification. Because of that, the mass production and supply chain, everything has been done very carefully. And the company production has been increased very significantly. Then third generation of industrial revolution is completely automation with the help of PLC and SCADA. In fact, the second part of this today's session, which is on security of cyber physical systems, it involves this third generation of automation as well. Because right now industry is at industry 4.0, but still there are industries which are still stick to industry 3.0, and they are dealing with combination of industry 3.0 and 4.0. So the industry 4.0 is completely based on cyber physical systems. This term might be new for most of you, but a cyber physical system is a system in which there will be a physical system and there will be a what we call control algorithm. So the interconnection of these two will makes the cyber physical system. So you can take cyber physical as today's generation cars and electric bikes, electric vehicles, robots, and substations, power stations, everything, everything. Every industry is now a cyber physical systems, and they have their networks. They're not talking with direct wires just on and off, they're talking with networks. And most of the industries are having their robots, and most of the industries have the industrial robots. So that's the main reason behind why I choose industrial robots for today's session and for my PhD as well. I'm doing PhD in completely based on industrial robots, not on the mobile robots, not on the humanoid robots. It's There is no other purpose. The only purpose is this is where I have started back in undergrad, which is doing bachelor's. So I want to continue my journey on this. So next, here comes the robotics. As you all know, robot is not just a single system. It will be having a sensor, it will be having an actuator, it will be having a mechanics, it will be having sometimes electric, sometimes hydraulic, sometimes pneumatic. There will be a lot of gears, there will be a lot of mechanisms. But a robot is meant to do the functionality of a human. It is meant to help the human, even in the industrial world, even in the automation, even in like home automation, even if you say in the military. And in today's session we'll be going to see like there were robots deployed in the military in the real time. So these are the application these are the classifications of robots in general. So if you see just robot as robot, but here's the classification. So this is not the complete classification. I'm sorry. So there are many more classifications of robot right now. So right now, just for today, I am focusing on this part, which is the industrial robots. So here comes the industrial robots. The main reason behind industrial robots is industrial robots are being used in the industry. There is no other reason. And industrial robots are the legacy of the actual robotics. And right now, in the automotive manufacturing industries, more than 70% of the industrial complete manufacturing and assembly lines are equipped with industrial robots. So I thought of like, what happens if this robot goes under cyber attack? The whole industry will collapse. If the industry collapse, so let me give you an interesting like a line. The motivation behind my complete master's thesis and complete my PhD is, let's say let's take an example. Let's say Ford is manufacturing vehicles, and as per the statistics, last year Ford's topmost sold vehicle is Ford F-150, which is a pickup vehicle and which is meant for the strength. And one of these industrial robots are working in that space. And there is a cyber attack, and because of that cyber attack, there is a small deviation in the welding. There is minute deviation. The quality and assurance team, they'll just check pass. Everything will be good. A few months, it'll run completely fine, until and unless they deploy the complete load on the vehicle. So when they deploy the complete load on the vehicle, it will break down. So the legacy of Ford will be destroyed just by one vehicle, not by one vehicle, by the whole line of the vehicle. So if this robot is in the manufacturing line, all the manufactured vehicles are from this robot. So those all vehicles will be having those defects. So they have to recall all those vehicles. Whenever there is a recall, the industry will lose their reputation. When the industry will lose their reputation, people lose their jobs. When industry lose their reputation, country will lose the economy. So just a single cyber attack can impact the whole country economy. So this is the only reason which motivated me towards my PhD. Otherwise, I was going for a job, and I was discussing with my professor, and this idea came, and yeah, here I am. So here's the detailed classification of industrial robots. So industrial robots are classified based on kinematics, the control method, which is open loop, closed loop, and power source, degrees of freedom. But today, I want to discuss more about based on kinematics, because in industry, when you go and when you talk about industrial robots, they don't say open loop robots, closed loop robots. They'll say either Cartesian robots, Scala robots, articulated robots, or delta robots. Let's see let's see the small animation on these robots. So Cartesian robots, they are operated in a linear fashion. There is no angular control in the Cartesian robots. Whereas Scala robots, they'll be having some angular control, but these robots, in fact, these are the one of the fastest robots in industrial robots. So this robot, the Scala and the Delta robots, these two are the fastest robots in industrial robotics environment. And the next one is the articulated robot, and which is the actual industrial robotic arm that we see like in pictures in industrial automation. And the next one is the Delta robot. So why the Delta came? Because of the structure of this robot. Because it'll be having three arms, and they'll be synchronized, and there'll be only 1 degree of freedom. So next, what if we integrate AI, the artificial intelligence, into these robots? It will give the perception, planning, learning, and collaboration. What is mean by perception? Perception, it is it actually there are a lot of subtopics which comes under perception, but I wanna address only two topics, which is one is computer vision, the artificial intelligent infused computer vision. So camera can act very intelligently. So nowadays, our cameras can detect a human, they can detect motion, and yeah, that camera vision. What if we deploy this camera vision into robots? Actually, this perception based AI in industrial robots are already deployed in the industry. So this can, so the general functionalities are, they scan the object, they scan the size, they scan the shape, sometimes they scan the color, and sometimes they count. So they're not only a single application, they're multiple. So the second idea which comes under perception is sensor fusion, which is my major part of my thesis. So perception, under perception, what if we combine vision sensor with thermal camera? It's just a vision sensor and thermal camera combined together. It will give rich data. Whereas let's take an example of gyroscope, which is the accelerometer, come angular based sensor, and a vibration sensor. So if we combine these two, it will give more rich data. So we are in a world where the only one factor which is the most important factor for everything, which is the data. Believe it or not, if you have the data for your model, 80% of your AI model is already built. 80% of your deep learning model, I mean, I can't say exactly AI, but if you are working with deep learning or machine learning or reinforcement learning models, if you have the right data, your 80% of job is already done. Because if you have the data, you can train based on that, you can extract the features, you can train your model based on that, you can observe the patterns based on the data, but you should have the data. This is okay when it comes to some other sectors, whereas let's say images, let's say script, because there will be a lot of examples, there will be lots and lots of data sets. But when it comes to hardware, when it comes to robots, when it comes to automotive, when it comes to electrical, there'll be no data set. That's where the problem comes. That's why uh, deploying AI, machine learning, and deep learning models into actual hardware is getting difficult day by day, because these beasts, I can say these monsters, which are the deep learning and machine learning models, they need data as their food, as their complete fuel. So if we have data, we won the match by 80%. So next is planning. So AI can actually help robots for planning. You can there is a debate that planning can be done without AI. Yeah, I completely agree. I saw robots which are operating in the industry from last 40 years, when there is no AI, when there is no deep learning. I mean, there is a deep learning, but there is no deployment of deep learning in those robots. But that robot is still working fine. I mean, I can't say super, but it's working fine. That's called pre-programmed robot. So the trajectory of the robot and the points and where how the robot should move, it's already defined, and it's a pre-defined path of the robot. Whereas with the help of AI, it can generate its path. It's not pre-programmed, and it can decide whether this path is better or this path is better by going in which path I'll be avoiding the obstacles, and I'll be reaching the destinations with least energy possible. So that's where the AI helps the industrial robots in terms of planning. When it comes to learning, uh, let me give you a brief example, brief intro of reinforcement learning. There is deep learning, there is reinforcement learning. In the deep learning, you will train your model based on your data set. So it's like you're training a baby based on multiple pictures. Yeah, this is mean by cat, this is mean by dog, this is mean by elephant, this is mean by kangaroo. But what if like they learn by themselves? They'll fail. Yeah, earlier initially they'll fail. If you're helping a child to walk, you will be holding him. Or there'll be a lot of children out there, they didn't learn walking by someone's help, they learn by themselves. But in their journey they'll fail multiple times. Whenever they fail, they learn from their fails. So that's exactly what reinforcement learning can do. So first it will run and it will fail. It will start planning and it'll fail, and then it'll come back, it'll train its model again, it'll deploy again, it'll train, it'll check, it'll fail again, it'll come back, it'll fail again, it will come back, until it reaches the perfect accuracy. But before that it'll fail multiple times. That's how I mean, during childhood, during childhood, or when we are young, there'll be a lot of people, or there'll be family who will be helping us if we fall. But yeah, when we go, the sad truth is we have to fail. We have to learn from our mistakes. Yeah, I learned this. Yeah, that's called reinforcement learning. The next one is collaboration, which is the cobots, which is it's not a new concept, but it's there in the industry from past couple of years, past couple of, I can say, decade or so. Um, in the collaboration robots, the robot will be having awareness of the person who's working around him. And in an industry, if a robot has to work in the manufacturing line, there has to be a fence. If it's not a collaborator robot, there has to be a metal fence around the robot working area, that called work zone. And no human is allowed to enter the zone when robot is in operation. To avoid that, they build this concept called collaborative robots. These robots can work along with the human. So I'm not a person who's just talk and talk. Even I don't have much patience to listen as well. Because, that's why, like, even during undergrad, like, I was the I was the person who has the least attendance during undergrad. I used to skip classes. I used to sit in lab. I used to work, and thanks to Bhavana madam and Ramesh sir and Swati madam to help me in that regard. So let me give you a quick demo of a robot. I have a robot with me right now. It's a industrial robotic arm. It's not actual industrial robotic arm. It's a replica of industrial robotic arm, but it works exactly as industrial robot. So let me see. Where I am right now. Yeah, here. Let me stop the presentation and let me share. Where is this window? I'll do one thing. I'll share the whole screen. Yeah, this is the robot that I'm talking about. So I'm sorry, my camera will be like zooming in and zooming out because I'm sitting here, so it'll focus me first. But we have to focus on robot. This robot is works based on the ROS 2, and it has a camera which is a 3D depth camera. It it not only captures just the 2D image, it can capture the 3D depth as well. So uh, I'm going to give you a small demo. So these are the controls that I can control through my phone. Actually, I can control through my laptop, but if I need to control through my laptop, I have to disconnect it from the Wi-Fi. So if I disconnect from Wi-Fi, I'll be kicked out of the meeting. So that's why I'm just controlling with my phone. So here is the app that with the help of that I can control the robot. So first, let's go with perception. So I'm not gonna demonstrate something which is not there before. I mean, which I didn't talk. I'm going to demonstrate the exact topics that I discussed in the previous slide. So I'm gonna go with the gesture control. So this is what the robot can see. How can I do? Yeah, let's do one thing. I'm here, and if I say two, come on, it requires more lighting. I'm sorry. Uh, yes, good, I guess. Gesture control and start. So now I have shown two with my two fingers. So there are some assigned tasks which are already pre-programmed, but this robot here can see, I guess, yes. So it captures not only my arm, it captures all the joints of my arm. Every single joint in my finger, it captures every single joint. So this is possible only with the help of deep learning. I mean, if I'm like a little exaggerating deep learning, I'm sorry, but that's what deep learning can do. And this is the perception. So I want to show you the collaboration. So once I'm here, it will track my face. Wherever I go, at what height, it will track my face. So I'm not controlling anything. My phone is here. It will track completely my face. Wherever I go. Don't do anything. This is just a small example of working with this robot. Recently, we were at, let me show you this one. Yeah. Hopefully, you guys might have enjoyed this live demo of this robot. There are a lot I can show, but I have to move forward because I have a lot of other things that are interesting. Actually, that are gonna create something sparking in everyone's mind because yeah, it'll be interesting. So let's jump on. So recently, the three people that you can see, like in the middle of the picture, that's me, and on the left side, her name is Jyoti, and on the right side, his name is Guna. These these three people are the alumni of P.V.P team, which is 2020 batch, and we all are batchmates, and we all are in year of India 1. So he's working in masters in robotics, and she's working in masters in computer engineering. She's her research is on automotive Ethernet and their vulnerabilities, and he's working on industrial robots, and I'm working on my PhD. So, without no further ado, I want to introduce the cyber physical systems. Actually, this is there will be small statements under the title. Uh, I took some time to create this one. It's bridging the gap between digital and physical worlds. Why? Let's see. So here's the definition of cyber-physical systems. Cyber-physical systems are engineered systems that are integrates physical process with computational algorithms to monitor and control physical environments. This is not software alone. This is the combination of both. So here we have the physical process or physical components. We have the computational algorithms as well. So the computational algorithms are deployed in computational components. So let's see what are those components. So the physical elements, it can be sensor, it can be actuator, it can be the whole process. So the process can be a robot that we have seen just right now, and the process can be a vehicle. The process can be an industrial machine. The process can be our electric motor. Actually, I love DC motors. I love motors. I have studied. Actually, my background is in diploma and BTech. I'm a lateral entry, so I love machines. But now I'm in robotics. All thanks to Bhavana madam and Swarti madam. So next, it's not just the physical components and the computational component. It's the major part where the actual culprit lies, which is the interaction. So here you have computational components, you have physical components. There will be integration. So this integration, it can be happened with the help of networks, and by integrating these all, we can able to do the real-time monitoring, decision making, control. Actually, it can blur the lines between the physical and the digital worlds. Yeah, it's interesting. And yeah, on the right side of the frame, the right side of the presentation, solar, wind, power stations, communication, even Wi-Fi, drones, vehicles, cloud, robots, humanoid robots, everything. Whatever you take, in these days, everything is considered as cyber physical system. Let me take just a small water break. Yeah. So here comes the security of cyber physical systems. Why the security is important? So there was a really interesting boom in in the world that cyber security. But that cyber security is meant for IT systems, which is information technology. But we are the people who are dealing with actual cyber physical systems. If you have an inverter, that's a cyber physical system. If you have a DC microgrid, that's a cyber physical system. If you have a smart grid, that's a cyber physical system. If you have a machine, even it's a hydraulic machine, that's a cyber physical system. If it has any control and internet connected communication or something. So security of these cyber physical systems is really important. So because as I mentioned, like every hardware that we see today is a CPS, and these hardwares are at critical infrastructures, and such as power grids, healthcare, because there are a lot of automations in healthcare. There are like robots that do the operations, and transportation, manufacturing. So securing these systems are really crucial. And what is meant by vulnerabilities? I mean, vulnerability is something like where the system is compromised, and what where the system is compromised, or during what factor the system is compromised. That's called vulnerability. So CPS are susceptible to various threats, including cyber attacks, including physical intrusions, including human errors. A human error can turn into cyber attack. So this is the topic not for today but for tomorrow. In tomorrow's presentation, like as part of my thesis and as part of my master's thesis and as part of my paper, so this human error will turn into a cyber attack intentionally. And what is the urgency? Because the attack on cyber CPS can have the serious impact on the country, complete nation, because it's a national security. Let's say if there's an attack on power grid, if there's an attack on complete like what we can say, the manufacturing components for military and their PLCs and SCADAs. If there is a cyber attack on PLCs and SCADAs, that's a national security. And the other thing is safety. So safety of human, which comes in where we are considering about transportation, which is the vehicles, and manufacturing lines and the robots. Because in these spaces there'll be people working around that CPS. Next, economic impact. As I already explained, like in the Ford example, one Ford F-150 reputation can can take down the whole company reputation. And a Ford company reputation will be having a like lion share in the whole country economy. If it's gone, it's gone. What if it happened to our Indian Railways? What if it happens to our transportation and distribution systems? We consider it's secure, but yeah, there are attacks happen, and yeah, it will gonna impact the country economy at the end. Next, even though like there is a really serious urgency, but there are challenges of building security, the cyber security in CPS, which is the complexity. Because here we are not only having the software, we are having the hardware, and we are having the integration. We are having the integration with sensors, controllers, processors. We are having the integration with memory. We are having the integration with actuators. There's literally a lot. It's having multiple networks. It's having a software network, it's having a hardware network, and there's interconnection between these two. So that creates a complexity. So that's one of the main reasons why building cybersecurity in CPS is really challenging. The next one is cyber attacks, the attack surfaces. Whenever it has multiple components, the attacker will be having multiple entry points. So if it's software, you can enter through system, through software, or through Wi-Fi, through plugged in. But whereas in CPS, which is the actual hardware, the attacker will be having literally multiple entry points. That's called attack surface. Attack surface is like the ways of attacker can enter into a system to attack the system. And threats range from traditional cyber attacks to physical intrusions. Physical intrusion, if physical intrusion happen to a vehicle, it's bad. I mean, believe me, it's really, really bad. Uh, a person can just attach what we call the OBD scanner. There'll be a small OBD scanner in the car, and that's it. The car is, even though you are driving the car, the person who just injected that OBD scanner, he'll be having the whole control on your car. He can literally control your car. He can apply brakes at very high speeds. So it's it's bad. So here comes the motivation. So there's a again statement. Embrace the unknown. Every groundbreaking idea was once just a spark of curiosity. This spark was ignited in 2023 uh, uh, during the talk with my professor, and that spark is just driving me in this whole journey. So here is the interesting facts. So here are multiple cyber attacks which happened on actual energy sector. So here is the nuclear power plant attack. So because there is a virus called Stuxnet, and because of this attack, whole country, more than 2 million people were 2 million computers were completely hacked, and there was a huge impact on the company economy. This happened in Iran. So the next one is in Saudi Arabia, and the next one, it's in Ukraine power grid, and it was one of the biggest what we can say, cyber attack on power grids. Because of this attack, there were 2.3 million people were out of power. So it was really bad, and the after effects on the country. Actually, this attack was conducted by Russia, because uh, yeah, there was a rivalry between those two countries, and Russia attacked Ukraine, and the next attack is also on Ukraine, and it's not a huge, but it was an attack. The next one is one of the biggest attacks on any energy sector, which happened in USA. Believe me, in USA, if something is happening, it happened big. Even it's good, it'll be big. And if it happens bad, really, really, really bad will happen. So that's one of the incidents happened in 2021. 17 states were not having gas, were not having petrol, were not having diesel. uh, no fuel was there for 17 states for few days. Just imagine how bad the situation was. And the next one is on a nuclear power plant, and there were lot of PLC and SCADA systems were compromised in this attack. And this attack was actually happened to Iran. So on the right side of our screen, we can see it's a DC microgrid. So here, with this small example, actually, I took this picture from one of the PhD scholars of Mahindra University. He was working in cybersecurity of DC microgrids. In fact, I was also working in that space. That's me. I mean, I work in multiple projects. So I worked on this one. So these four units, in fact, we call them as nodes. So these four nodes were contributing to the whole grid. If there's an attack on any particular node, whole grid will be compromised. If there's an attack on the network, the communication network between node to node, it's compromised. If there's an attack on sensor of one of the node, still the whole grid will be compromised. If you want to see how, just search Dr. What's his full name? Dr. Suprabhat. His full name is Sriranga Suprabhat. So he did it. I mean, his living genius. He was amazing. It's just an example how attacker can enter into a system. So it's a communication network. So in this communication network, an attacker injects an attack on one of the network of node 2. You can have the whole complete network's data, and it can control the complete network. And sensor attack and node hijacking, node replay attacks. I'm going to discuss about these attacks. I mean, the types of cyber physical attacks tomorrow. That's for tomorrow. So let's discuss a little further about this attack, which is on US oil resource. This attack happened on Colonial Pipeline. In this picture, you can able to see it starts from Texas. It all the way goes to the top of Manchester. So Massachusetts. So almost all 17 states, including Florida. Florida is not out of the danger. So include all the states were out of fuel. Like there is no fuel. few days. So the FBI was working, everybody was working, they were unable to find out. And the attackers have demanded a ransom, which is of 75 bitcoins. That time the value was 4.4 million. Now the value is 7.8 million dollars, and they have to pay, and they did pay. And after that, attackers let go, like they released the pipeline, but still money is gone, and nobody was unable to find out who did that. Yeah. So here comes the cyber attacks on the automotive sector. It's actually interesting topic for this current generation of automotive, because every automotive, they are like having their ADAS features, which is advanced driving assistant system features. But they of most of them are forgetting, whenever you are adding a new feature, it will add a new entry point for an attacker. Whenever you're adding a new component, it will add a new entry point for attacker. So that's what happening from more than a decade. So the first Jeep Grand Cherokee in USA, it got hacked. I mean, they just hacked the canvas, which is the control area network of in-vehicle network. They hacked that network and they unlocked the vehicle and they drove the vehicle. So it happened to not only this one, it happened to most of the listed attacks here. But one of the interesting attack that I found is like, which is not actual automotive attack, but it is a scary attack, which is Honda cyber attack. June 2020, there was a cyber attack on Honda. Because of this attack, they have to shut down their customer service, what we call customer service stores for a long time, and there was nothing happening. They don't know how it happened, but attacker has used a attack called snake. But attacker didn't use there is a interesting report after this attack and attack mitigation. There's an interesting report which says that attacker didn't use the full potential of snake. If the attacker had utilized the full potential of snake, complete Honda software will be destroyed. That's powerful. That powerful attack was, but somehow attacker, I guess he didn't choose to, or he's not aware of, because most of the attackers, even most of the developers, when they're working with any cyber attack, they don't know what is the potential of that attack, what is the potential, what it can do, what's the extremes. Not only in terms of attack, like even if you take a machine, we always go with the functionality, we always go with how it works. We never look into what it can do in extremes, like what is extreme conditions. So if we check that, we can do a lot. So till now, I know I scared you guys more, but here is the security. If there is an attack, there will be security. If there's a fail, there will be success. So the same way, here is one of the ways that we are dealing with this cyber attacks. So we are working with something called physical fingerprints. So I'm just going to give a brief. I'm going to talk a little more detailed into more session, because yeah, that needs a separate time. So this system that you can able to see here, it's a actual truck's complete electrical system. It has all the ECUs, it has gear, it has acceleration, it has brake. So if you ask me like where is the acceleration, there will be pedal here. So that's acceleration. And this white knob, it's actual brake. And you can say that it's just a prototype. No, it's not a prototype. It's a test bench developed by GMC. So the Chevrolet that we can see in India. So there is a company called GMC, so General Motor Vehicle. So this test bench was built by GMC, and it's a real-time test bench that they use to test their vehicles. So we got this test bench, and we were able to capture uh, the signal. So this signal is the actual CAN message, and in the CAN message there is a interesting pattern which is which we named as fingerprint. So with the help of that fingerprint, we are identifying whether the data came from an attacker or it's an authentic data. So we are verifying the authenticity, and we are in fact blocking, if it's from attacker, we are blocking the data as well. And on the right side, it's just a small test bench that built by me and some of my students. Yeah, I mean, if I'm mentioning as my students, I'm a student, I'm a PhD student, as well as I'm a graduate instructor. So I teach as well in the University of Michigan Dearborn. So that's why I built this one with with help of my students. And there is a version 2.0 which will be coming probably in next 3 to 4 days, which is almost done. Like myself, Guna, and Jyoti, we three are working on the test bench, and it will be done in next probably in a week, and it'll be really interesting. Next, the other area of where the cyber attacks can happen is the multimedia. So during the Ukraine and Russia war, there was a video which got viral. There is a viral video in which the Ukraine president is saying that no, I can't do this, and I'm surrendering myself to Russia, and so and so. But that video was generated through AI, and and nowadays everybody is witnessing the AI generated videos, AI generated audios. So this solution is to verify whether the audio is generated or audio is recorded or it's alive. I mean, as I'm talking, it will verify whether I'm talking right now, or it's recorded, or it's a AI generated, or someone is mimicking my voice. So that's one of the products that we have built in a lab. So here's the legend, my professor, Dr. Hafiz Malik, and here's one of the PhD students under him, Hashim, and here I am. And there's a industrial mentor for us. He's from industry, and the whole training was sponsored by NSF, National Science Foundation of US government. And as I mentioned in the first slide, it's it's kind of once in a lifetime opportunity for me, because I heard that like this training max, any person can take this training max only twice or thrice in his whole life. And there should be at least a couple of years of duration gap between each training. So, and we have to do the customer discovery interviews. So this training, I forgot to mention, like this training is meant for like how to convert a project into product, how to find its value in the market. That's what we have to do. Now, we are inventors, we are engineers, so we build systems, we build ideas, we build prototypes. But we have to learn how to convert this projects, these ideas, these prototypes into an actual product. We have to find out what is the value in the market for our projects. Next, here is a series of incidents on cyber attacks on robots. So it's actually scary. So there is a cyber attack happened on a robot which is ABB robot, which is one of the biggest robots of ABB, and it was not done by an attacker. It was done by a professor in Italy, in what is the university name? IIT Italy, Italian Institute of Technology, and he was able to perform 50 plus attacks on the robot, and he demonstrated to ABB that yeah, I can hack your robot, just find a way to defend that. And now he built a company based on that. And there are series of attacks, but there is an interesting attack which is during Ukraine Russia war. So during Ukraine Russia war, uh, there were some intruders. There were some attackers from Russia, Ukraine. They hacked Russian robots. It was a war. I mean, it's like a win-win from both sides. So Ukraine attackers deployed a cyber attack on robots which were doing the patrolling in the airport, and they hacked the robots. They took complete control on the robots, and they also took control on the visuals of the robots. The robots capturing the visuals, and without any hesitation, they like posted in the social media. They are attackers. So they can, and that's a war, and Ukraine was on their side, so they can do that. So they were able to control the whole robots, its controls and its visuals, its location, everything. Just imagine, that's not a petrol robot, that's actually a military robot that is meant for shooting, or that is meant for deploying mines, that is meant for some crucial functionalities in the robot, in the military. What happens, a cyber attack happens on those kind of robots. It's really, really scary. So with this one, I want to conclude today's session. I mean, I know it's little early. I know Bhavana madam told me that, like, go a little slow, but um, this whole time I wanna give it to you guys, everyone. I wanna give it to everyone. Just shoot me questions. I'll try to answer your questions. Sometimes, yeah, from questions we'll find innovation. So let's see. I mean, I'm open for questions. And before the question session, uh, big thanks to Bhavana madam, because she was my mentor during undergrad, during my bachelor's, and she sponsored for most of my projects. And when we won prize money, she said, like, it's your money, just keep it. She spent money on my projects, and when I was there to repay the amount, she said, no, 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 it was just a small support from my end, so it's all yours. And she's the main reason behind why I'm in USA. She in my career, her role is one of the crucial role. And special thanks to Swati madam, because she's the person who introduced me to robotics in the first place. So for the first robot that I have worked with, that's with Swati madam. And Ramesh sir, he gave a lot of exposure by working, allowing me to work on his robots, which is seed plantation robot, and his solar mover. And thank you everyone, and I'm open for questions. If you have any questions, just you can ask.
Thank you, Karim. That was really wonderful and a great insight to our participants regarding the cybersecurity and in robotics, and how AI is playing a role in cybersecurity and robotics. That was a great thing. And request all the request the participants, if you're having any queries or you want any like resources from his side, he will definitely share to you. You can ask the questions either in chat box, or you can unmute yourself and ask the questions. Karim?
Ma'am,
Yeah, that was a
to end
great
this session,
insight. Yeah, yeah. Yeah, yeah, pardon.
I mean,
You can
to end this.
like you if you can give some like other what do you say, like what kind of research can we move on actually. What from your side, what I understood is like we have like more amount of research was I think it is on the way, like, right? It's not like it's a new burning topic, that cybersecurity attacks, right, in robotics and all, right?
Yes,
Yeah,
ma'am.
any keen areas where the researchers who are interested in robotics can work on? You can give some
So,
insight to it.
yeah. So, let me give a quick entry points where the people can start quickly start working on working in the industrial robots cybersecurity. Let me share my thesis, master's thesis with all of you. So you can.
You can just tell on any of you are going to discuss that tomorrow, right?
Yes, ma'am. I mean,
You can
we
give some of the topics like where the emerging the research is very new to that particular topics, where where the like researchers and participants or faculty can work on it who are really
yes, ma'am.
interested in this area.
So
Some
the
sort of
first.
some sort of areas like within a short a few couple of you can give on.
Sure, ma'am. So in terms of robotics, I can say that uh, we can work on something called networks of these industrial automations. So there are not only a single network, there are multiple networks. So there is CAN, there is LIN, there is automotive ethernet. So we can there is TCP/IP, there is UDP protocol. So if you guys are not familiar, you can work on this. If you are not working on if you're not familiar with this, yeah, we all are familiar with sensors. So we can directly start with sensors. So working with sensors and their vulnerabilities, that's an entry point. That's where I am working on. So if you need any like further information of how a sensor can impact a robot, that's actually I have attached my the link of my thesis in the chat. Anyway, I'm going to discuss that one tomorrow, and I'm going to discuss my recently published paper, which is on one of which is purely on sensor vulnerabilities of industrial robots. And the other part where we can work on is the actuators. Don't consider it as like a cyber attack as a cyber attack. Just consider it as a fault. What if a fault in any industrial robots, let's say a fault happened, we say that it's just a fault. But what if the fault is intentional? That's a cyber attack. So if if there is a if something is happening without unintentionally by an attack by actual developer, that's a cyber attack.
Abdul sir,
Yeah,
Abdul sir,
go ahead. Yeah.
sir, I have one doubt, sir. Actually, small doubt. I am from Ballari Sanjay Gandhi Polytechnic. You
Okay.
said that present now exactly TCP/IP and UDP. TCP/IP is the with wire connection, and UDP is nothing but it's a wireless connection. It is only applicable for industrial applications for like that steel plant, ispat steel. Not only for you can use for medical and manufacturing, it like as a cotton mill, ice factory, fish net factory, you can use industrial.
Yeah, yeah. Actually, yeah, that's a great question, because Earlier, these networks were dedicated to some functionalities or dedicated to some industries. But now, these every industry is going towards the automation. They have PLCs, they have SCADA, they have the control systems. So to build a network, to build communication between all these systems, yeah, these networks are being employed in the industry. That's yeah. I hope I answered your question.
So, but UDP, how can you without wireless connection to how can you operate some machine exactly? As you said, and
Yeah, actually, UDP we can do it with wire as well. That's actually happening in automotive Ethernet. Because in the automotive Ethernet there will be 7 layers. So from layer 1, which is the physical layer, which is the lower level layer, and there is a layer 7, which is the higher level layer. So the UDP, which stands in, I guess, layer 5. I guess layer 5. So earlier that was only meant for Ethernet. Now it moved towards to automotive Ethernet or the industrial Ethernet. So industrial Ethernet and automotive Ethernets are little different from actual Ethernet. So there is a UDP protocol within the hardware wire-based Ethernet, which is automotive Ethernet. That's why I mentioned the UDP.
thank you, Abdul Karim sir.
Thank you
Thank you,
so
sir.
much.
For elaborating of the TCP/IP and UDP with wire and without wire connectionless. You can said that exactly. It's a good point. That is the what I want. That point is exactly. Thank you so much, sir.
Thank you so much, sir. You're most welcome.
Okay.
Yeah, I mean, do you continue, or is anyone is having any
No,
doubts?
no, actually, yeah, yeah. We'll see for 2 more minutes and then we can wind up, Karim. Yeah.
Sure, yeah. Like I'll be talking for a few minutes. Like if you have any doubts, like just stop me in between and I can ask out. So not only with like in the robots, you can work on sensor. So in my thesis, I also mentioned that uh, not only faults, the limitations of a sensor can turn into vulnerability, which is cyber attack. So tomorrow I'll be discussing that one in detail. But to start with the actual cyber attacks, if you want to start with the cyber attacks inspired by actual cyber attacks which happened on IT, then start with the networks. If you want to start cyber attacks as physical layer security, then start with actual components. That's what I can say, because I worked on network security, I worked on hardware security. But if you are interested in working on just the attacks, not on the physics, then go with like network attacks, network security. Whereas if you are interested purely in physics like me, then go with the actual hardware, because that's where you can utilize what we can say, the actual physics of the component to create the attack and to mitigate the attack as well. So this is one area. So if there are people from electrical background, I want to give electrical or electronics background, I want to give one more idea, that is cybersecurity of DC microgrids. That's actually emerging technology, and that's much needed technology for this generation right now, because all the substations are getting automated, everything is cloud. So there are multiple ways to hack the network, and even the sensor are getting smarter and smarter day by day. So now we have to figure out ways to defend these attacks. And when it comes to electronics, yeah, there are attacks on PLCs and SCADAs. There are attacks on actual microcontrollers with the help of their clock. I mean, when I started studying on cyber attacks, on physical layer cyber attacks, I mean, it's just I was just blown out because I mean, I thought of like, oh, you can do cyber attack on this part as well. That was amazing experience for me. And yeah, if you need any suggestions or if you have any doubts, sorry, you can ask me. And yeah, I'll be leaving my email ID in the chat box. So if you have any doubts, just send an email. So I'll provide the details. Yeah, I sent my email. Bhavana ma'am, that's all from my end.
Yeah, Karim. Yeah. So if anyone still have any like discussions with Karim, we can go on or we'll wind up the session. Thank you, Karim. That's a great thing that we have here today for this
Thank you.
session. Thank you for your insights and whatever you have discussed today. Definitely, it's very useful for our participants. Thank you once again for accepting our request and coming forward to give your lecture. Thank you.
Thank you so much, ma'am. And
Thank you.
Bhavana ma'am, if you ask me, like I can come like many
Yeah,
times.
yeah. Thank you so much. Thank you. Thank you. Thank you, one and all. We'll meet in the afternoon. It is the afternoon session will be at 3:30, 3 o'clock. Sorry, 3 p.m. sharp. We'll put it in the group. Thank you, one and all.
Thank you so
Thank you,
much.
Karim. We'll meet you tomorrow. Thank you.
We'll meet you tomorrow, ma'am. Thank you so much, everyone.
Thank you. Thank you.
Thank you, sir.